Hey guys, here's another example of the instantaneous rate of change. So remember ROC is the limit as h approaches 0 of f of x plus h minus f of x all over h. So first we know that f of x plus h is 1 over square root x plus h minus f of x, which is 1 over square root x, all over h, but they want x to equal 4. So is the limit as h approaches 0 of 1 over square root 4 plus h minus 1 over square root 4, which is 2, all over h. So now we need to simplify this complex fractions by doing common denominators. I'm going to multiply this one by square root 4 plus h on top and bottom, and this one times 2. So this becomes the limit as h approaches 0 of 2 minus square root 4 plus h all over 2 square root of 4 plus h. And then that is being multiplied by 1 over h. So now I can multiply by the conjugate of this numerator on top and bottom, because as is, if I plug in h, I'm still going to have 0 in my denominator. So it's the limit as h approaches 0 of 2 minus square root 4 plus h times 2 plus square root 4 plus h over 2h, because I'm multiplying those two, square root 4 plus h times 2 plus square root 4 plus h. So now these here are conjugates. So they're going to be a difference of squares. It's going to be 2 squared minus square root 4 plus h squared. And this is all over 2h square root 4 plus h times 2 plus square root 4 plus h. So when I square this square root, I have the limit as h approaches 0 of 4 minus 4 plus h all over 2h square root 4 plus h times 2 plus square root 4 plus h. Distributing this negative, 4 minus 4 cancels, and then I'm left with negative h over 2h square root 4 plus h times 2 plus square root 4 plus h. So now that I've done that, my h's cancel. I've got the limit as h approaches 0 of negative 1 over 2 square root 4 plus h times 2 plus square root 4 plus h. So plugging in 0, this becomes negative 1 over 2 square root 4 times 2 plus square root 4. So that's 2 times 2, which is 4, and 2 plus 2, which is 4. So it's negative 1 over 16. So this problem was interesting because you not only had to do simplifying a complex fraction, but once you got it into the fraction form, then you had to multiply by the conjugate of your radical expression in order to cancel. So that's definitely an interesting problem.